You know, when you look at a router or a switch, what do you see? It's this incredibly powerful piece of hardware, right? The very backbone of our digital world. But it's just a box. There's no screen, no mouse, no keyboard. So how in the world do you actually tell it what to do?
That's the big question we're going to tackle today, because the answer? Well, it unlocks the entire world of network management. So, let's figure out how we can finally have a conversation with these silent, powerful machines.
So, the first step is to understand what's actually going on inside that box. Just like your computer runs on Windows or Mac OS, a network device has its own special software. It has a brain that lets it think and act. And for Cisco gear, that brain is called the IOS, which stands for Inner Network Operating System. The analogy here is just perfect. iOS is to a router what Windows is to your PC. It is the fundamental software that makes everything else even possible.
So what does this brain actually do all day? Well, it's doing all the heavy lifting, figuring out the best paths for data, directing traffic locally, and keeping an eye on security. But most importantly for us, it gives us a way to talk to it, and that's called the Command Line Interface, or the CLI.
Okay, but this brain isn't just always on. When you plug a device in, it has to wake up. And this isn't just a simple flick of a switch, it's a specific process where the iOS gets pulled from its permanent home into active memory so it can actually start doing its job. To really get this boot up process, you need to know about the 3 different kinds of memory in these devices. Think of flash memory as the device's hard drive. It's where the iOS software is stored permanently. Then there's RAM, which is the active, working memory. It's super fast, but it forgets everything when the power goes off. And finally, you've got ROM, which holds a tiny, can't-fail backup program just in case.
So it all comes together in this neat 3-step dance. First, you hit the power, and that little program in ROM kicks in. Second, that program goes and finds the full iOS on the flash drive and loads it up into the fast RAM, and boom, step 3, the iOS is now running live from RAM, and the device is fully awake and ready for your commands.
All right, the device is awake, the brain is working. So, how do we actually start that conversation? Well, it turns out there are 2 main ways to connect and start telling it what to do.
We can break them down into local access and remote access. Local is exactly what it sounds like. You're right there, physically plugged into the device. Think of it as a face-to-face chat. Remote access is when you connect from somewhere else, over a network, kind of like making a phone call. And for that very first face-to-face conversation, especially when you pull a device straight out of the box, you have to go local. I mean, it doesn't even know it's on a network yet, so you can't just call it. You have to use its special little port called the console port.
The console port is your lifeline. Seriously. It's a direct physical link you make with a special cable, and it's absolutely critical when you're setting up a device for the first time, or maybe more importantly, when something goes terribly wrong and you need to get in and fix it. It gives you full direct access to that command line interface we talked about.
Now, once that device is all set up and on the network, you can start having those remote phone call conversations. But this is where things get really serious, because not all remote connections are safe. Security becomes priority number 1.
This brings us to the big showdown, Telnet versus SSH. And let me tell you, it's not a fair fight. Telnet is the old, insecure way. It sends everything, your username, your password, all your commands, in plain text that anyone on the network could read. It's a huge security risk. SSH, on the other hand, stands for Secure Shell, and it encrypts the entire conversation. The rule is simple. Always use SSH for remote management. Telnet is only for when you're totally isolated in a trusted lab.
And every network service has an address, a port number. For the insecure plain text Telnet, that's port 23.
And for our secure encrypted hero, SSH, it's port 22. That's the one you want to remember.
Now, you might also spot something called an aux port. And yeah, this one's kind of old school. Think of it as an emergency backup line. You could literally hook up a modem to it and dial into the device if the main network ever went down. It's pretty rare to see it used these days, but it's a clever little backup plan to have in your back pocket.
So we've covered a bunch of different ways to connect, right? The real key is knowing which one to use and when. It's all about picking the right tool for the job that's right in front of you.
So let's just put it all together in a quick cheat sheet. If you've got a brand new device, you're using the local console port for that initial setup. For your everyday, secure management over the network, you are always using SSH. Telnet, that gets left in the lab, and that aux port is for a super rare dial-up emergency.
Knowing these rules is the absolute key to managing a network effectively and securely.
We've just spent all this time learning how to access the powerful command line interface. For decades, this has been the only way really, that network engineers built and manage these massive networks. But with automation and smart graphical tools getting better every single day, you've got to wonder, will the command line always be king?